सर मैंने स्क्रीनशॉट डाल दिया उस क्वेश्चन का, आप वो यूज कर सकते हैं।
This is which year? 24, is it?
Yes, sir. August 24 का है, sir.
This is the question number 2 you're talking about, right?
Yes, sir. Question number 2, sir.
So something is cancelled out there, is it?
Yes, sir. Actually, नीचे का भी बिल्डिंग का उन्होंने थोड़ा बहुत डाल दिया था, तो उसके बाद करेक्शन आया था उसमें.
Okay, okay.
करेक्टेड क्वेश्चन डाल दिया है, if you want to have a look in the.
नहीं, अगर यही है तो ठीक है. If this is the corrected question, you tell me if there's something else better. Is this the one? A uniform beam 16 meter long, 160 weight, supported at 2 points, a load of 15 kg from at a point 6 meters from end A, uniform weight of 30 kg spread over a length of 5 meters from end B, SF and BM. What is the maximum value of BM and what is the point where it occurs? Is this the correct question, beta, or there is something more to it?
Yes, sir, correct. This is the correct.
Okay, I'm surprised you are having doubt, but never mind, it's okay. Because you must be missing out something in the diagram only then.
Yes, sir.
Yeah, you must be, let me make the diagram by self quietly. And you let me know whether if it is same. Uniform beam. This is the beam data. Let's name it AB, though the question is not given, you can name whatever you want. Length is 16 meters. Weight 160 kg at the rate of 10 kg per meter. It is supported at 2 points, so this is 8, this is 4, it is supported somewhere here and supported at similar distance from here. So this is 2 meters, this is 2 meters, and carries has a 0.6 meters from end A, 15, okay, 6 meters would be somewhere here, 4 plus 2, 6, 15 kgs here. This is 6 meters, so that means this will be 4 meters from here. And a uniform weight of 30. So let me just use a different color so that you don't get confused. Uniform weight of 30 kg spread over 5 meters from end B. So 2 and 2, 4 and 1, 5. Here you have 30 kgs. At the rate of 6 kg per meter, and this distance will be 3 meters from here. Why? Because total is 5 meters, and then you have 6 and 5, 11, and then you have this as 5 meters. Am I right, guys? Have I done it correctly?
Correctly, sir, correctly.
So is this the diagram you have made?
Yes, sir.
Everybody who has tried solving it, I'm sure this is the diagram you have made. If you have not made this diagram, then obviously the answers would not match. Now I need 1, 2, 3, 4, 5, 6 points here. So I can name them whichever way I name. P, let's say P, Q, R, S, and A and B are named. So there will be reaction at P and reaction at S. Okay, we can take moments about P, and we'll have basically Rp into 0, taking clockwise as positive. Then we'll have 15 kg at 4 meters causing clockwise, so 15 into 4. Then we have the weight of the beam acting at mid length, so 6 meters from here. So here will be the thing. So plus 160 into 6. Then we have the 2 meter, 5 meters at 30 kg is also causing clockwise, so plus 30 into that will be at a 2.5 meters from end. It is over 5 meters. Yeah, over 5 meters, 2.5 minus. So 16 minus 3 is 13, 13.5 minus RS into 0. So 1, 2, 3, 4, 5 is equal to 0. Have you written the reaction equation correct, beta? Yes, or you messed it up somewhere?
I messed it, sir. 11.5. 30 into 11.5.
Okay, but that is 13.5, no? Because it will be 2.5 meters from end B, right? So it will be 16 minus. Sorry. It will be 11, right? You are right, beta. Sorry, my mistake.
11.5, sir.
No, you are right. Sorry, you are right because it is not at the end. Okay, fine. So what is the RS you got? No, you're right. I was wrong. Okay, what is the RS you got?
Sir, RS I got 113.7.
113.75.
75.
Okay. Let me make it 8 just to keep it simple. Don't worry. Okay.
Sir.
And the total is 160 plus 30, 190, 205. So RP will be equal to
91.25.
21.
91.25.
91.25.
So in by 0.2 kar dete hain, we made it 8 there, na? Okay. Right, beta? Because the total will be okay. So this is 10, 1, 4 and 1, 5, 1, 9 and 1, 10, 205. Okay, fine.
Yes.
The reaction at RP is concentrated, 91.2 kg. RS is 113.8 kg, but it is not concentrated. We divide by how much? 5 meters. So it will be 2, 1, 2, 7, 6. So something 7-6 kg per meter, whatever it comes. I'll not need that. It's okay. Okay. Now we can make the SF table for. So you had a problem in BM or SF?
BM, sir, BM.
Okay. And let's make SF table for 1, 2, 3, 4, 5, and 6 points.
2, 3, 4, 5, 6. Yes, sir, 6 points.
1, 2, 3, 4, 5, 6. Unit of SF will be kg.
Yes.
Points will be A, then P from my diagram, then Q, then R, then S, and lastly B. There are 3 concentrated forces at P, at Q, and at. Okay, this reaction is also concentrated. Why have I divided? This is concentrated, no? Sorry. And S, EQRS. This reaction, yeah, it's the UDL. It's not the reaction which is uniformly distributed. Reactions are both concentrated. Okay. Now, at A, SF will be 0.
Yes, sir.
At P, it will be 0. And weight is 10, so minus 20. It will be minus 20 here. Correct, beta?
Correct, sir.
Minus 20 plus 91.2 plus 71.2.
Yes, sir.
Plus 71.2, then you have 4 meters minus 40. Please correct me, I'm doing it on the run, so I'm not. Sometimes I may make an oversight. Minus 15 will be minus 6 plus 16.2.
Yes, sir.
We carry forward plus 16.2. Then we have 5 meters, so minus 50. It will be minus 8, 3, 33.8. Minus 33.8 here, and then you will have
UDL also.
no, this was at R, right? But why I have divided R into 2? S has to be divided. R is not required to be divided.
Yes,
S is to, so R will be 33.2. Okay. Then up to S, it will be concentrated. So up to S. Now, I think your problem would be at S. So minus 33.8 we carry forward. Then you have how many? 3 meters of UDL. So 3 meters of UDL is minus 18. And you have 3 meter. That's all you have, right? Correct?
No, sir, 10 meters of this beam also.
3 meters of beam. 3 meters of beam, right? From R to S, right?
Right, sir.
So minus how much? 30?
Yes, sir.
So it becomes how much? Minus 6 and 8, 14. 1, 4 and 1, 54.8. Am I right, guys? Minus 54.8? No.
Actually, sir, what
14, one second, 14 and no, so it's 30, no? It's okay. I'm totaled up wrong, yaar. This is 0.8, okay. Then 0 and 3, 11, 1.
81.2.
10 and no, beta. 7 and
अरे
10.
एस को भी डिवाइड नहीं करना है ना सर, यूडीएल है
इसको
एस को, यूडीएल है सर ना, पॉइंट फोर्स नहीं है.
S पे RS is point force ना बेटे, it has to be divided ना. Why? Reaction is not point force.
But sir, spread over entire length 3.
अरे RS reaction.
Yes sir. Point
Is
force.
it is a point force ना बेटे. अरे this force RS is not a point force बेटा.
Sir, point force ही है.
Yeah, so why it will not be divided बेटा?
But मैंने यूडीएल के लिए क्या किया था सर, आर पे जो अपना 33.
नहीं, listen. First, let me make the table again. I was trying to be miser on the space. Let me make it neatly. Don't worry. I think if there is a confusion, let's not worry about it. Let me do it a little bigger. So 1, 2, 3, 4, 5, and 6. Okay, fine. Okay, guys. Firstly, let's put the points. It's SF in kg. A. Now you let me know. Let me do quietly, and you let me know. I'll be talking to you, and you can interject anytime. When I'm saying let me do quietly, it does not mean you don't interject. What you did, I do not want to go into it, because if you have not done this way, then obviously you would have missed out something. I look at the diagram, guys. There are 3 concentrated forces. One is RP. So at P, it is divided. At Q, 15 kg, it is divided. And at S, the reaction is also to be divided. At RS is a point force. Does everybody agree with this? Yes or no?
Agree sir, agree.
Yes.
Okay.
Totally agree sir.
Yeah, so reaction, this SF at A will be 0. I carry forward 0. Now I'm speaking. If I was doing myself in an exam, this is how I would be doing. From A to P, left of P change is 2 meters of beam weight. So it will be minus 20. Now there will be no mistake when I start talking to myself. I carry forward my minus 20. And when I go just to the right of P, plus 91.2 comes into picture, making it plus 71.2. I carry plus 71.2 to the next one. And from right of P to left of Q, you have 4 meters weight of the beam minus 40, making it 31.2. Okay. I carry forward plus 31.2, and I have then minus 15 coming into picture, and that makes it plus 16.2. I carry forward plus 16.2 at just to the right of Q, and up to R, you have 5 meters of weight of the beam, and this becomes 8, 3, and 3. Am I right, guys? Up to this place, addition subtraction is right.
Addition subtraction is good sir.
Okay, now we carry. Now pay attention here. This is where you were raising the doubts. Now
Yes,
look
sir.
at the beam. What are the changes taking place from R to just left of S? There are 2 changes. One is 3 meters of beam weight, which is acting downwards, and you have 3 meters of reaction. 3 meters of weight of the beam, and 3 meters of UDL.
minus 30
and
or
3,
minus 18.
Yeah,
Yeah,
3 meters of UDL. 3 meters of UDL. So minus 18. Correct, beta? These are the 2 changes.
Correct sir, correct.
From R to left of S, there are 2 changes. Weight of the beam 3 meters and UDL of 3 meters. Right, guys?
Correct sir, correct.
And that makes it 8, 11, 1, 7, and 1, 8. Minus 81.8, guys. Correct? Please see. Am I correct? Okay.
Correct.
Then we take minus 81.8, and the moment I go to just right of S, I'll have plus 113.8 coming into picture. That will leave me with 0, 2, and 3 plus 32. Correct, beta?
Correct sir.
I
Yes, sir.
carry forward plus 32, and then I have 2 meters of the UDL. UDL is at the rate of 6 kg, so minus 12.
Minus 20, minus 12.
And minus 20 is the weight of 2 meters of beam, making it 0. This is the SF table.
Yes sir.
Was
I
this the you did, or something else you made?
Something else, sir. Actually, I made it on the R, so that's makes me
Okay.
realizing my mistake.
So if you keep talking to yourself, you see, when I was silently doing, though I made a small table, but if you do it neatly and talk to yourself clearly, chances of making mistake. You have to focus from one point to another. What is the change? And see how many forces are changing. Is that clear to everybody, class?
Clear, sir. Clear.
Will you be able to do now this, or you
Yes, sir.
still
Yes,
have a
sir.
doubt?
No, sir. Now I will do it. Now I know my mistake where I'm making it.
Okay. Anybody else who has a doubt, since the question is on display, please let me know. Once the SF diagram is made, then it is by areas. You get the BM diagram, right?
Right, sir.
Yes. Anybody in the class who wants any clarification before I continue? So guys, if you have any more problems, you can always, even from the previous topics, if you have doubts from past papers, you can always bring them to the class. But as I have been repeatedly saying, let's talk about the question. Let's not hypothetically create scenarios, because please understand that you guys will not be able to create the right scenarios every time. Sometimes you may create correctly, but most of the times it will be unnecessarily or cluttering your mind and thought process. If you are able to solve MMD questions, then where is the doubt? You should not be doubting your capability. Can I move on further then, if this question is settled?
Sir, with the homework sum, sir,
Yeah.
with the homework sum, sir, can you please share the solution so that I can compare my SF table?
That was the last question you're talking about, right?
That's correct, sir.
I'll discuss that. Later. Don't worry. During the day class only we'll discuss it. Don't worry. Okay.
Okay, sir.
Okay. So I'll first bring in the questions we had skipped in between. Okay, beta? That is the cantilever. Guys, did you manage to see the video for cantilever?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah, guys. Now let me just tell you, some of you may have done phase 2 long back from some MTIs, and let me just tell you, cantilever was being taught not the right way. I will refrain from using a negative word, wrong, but it was not being taught the right way in most of the institutes. And what happened in one of the online classes, because when you do physical classes, your boys are tuned to your teaching, and they don't come out with comparison. Now in this group of 40 odd of you, there are people from different MTIs. So one day in one of the batches, so somebody raised that we have been taught the other way. And then everybody started speaking in the class. Yes, this is not, this is what, this is it. Okay. Guys, that's why that video was made, to probably, because what happens is people put cantilever questions, and if they're teaching wrong, then obviously the solution submitted to the DG will also be wrong. And that's why this video was made. And I told the boys, I said, the only way I can help you out is once the video is out, you forward to your faculty and say, sir, do you have any comments on this video? Because we have understood the different way. Can you tell us what is wrong with this video? And I hope now, more or less, the things have been streamlined. But still, if a past paper comes, DG still may be sitting on a wrong solution. Okay, so I don't want to go into it. So if a cantilever comes, you just follow whatever is the right way. And if everybody is following the right way, they'll be forced to review the solution also. So don't unnecessarily doubt yourself. Guys, in all the questions that we have done until now, the beam was supported at minimum 2 points, correct? It was supported at minimum 2 points, maybe more than 2 points. In some cases, it was completely resting on the plane surface. That means it was supported all along the length. Somewhere it was supported on or over a certain length. And minimum, there were 2 supports every time. There was not a single case that we have done where the beam was supported at 1 point. Yes or no, beta? Am I right? Correct? Yes, class? We have done only
Correct, sir.
minimum with 2 points.
Yes, sir.
Now, if you have a beam supported at a singular point, then that forms the cantilever. But before I go to cantilever, in all the questions that you did, the beam had 2 free ends, A and B. Free ends means the end points. Free ends. What was the SF at the free ends in all the cases you have solved so far, beta? What was the SF coming at the endpoints? There is a
Zero.
table on
Zero, sir,
display.
zero.
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 What was the BM coming at the endpoints, free ends?
Zero.
Zero.
Zero. Guys, why BM has to come zero? What is, see, bending moment was called bending moment because you are not allowing the beam to rotate. But otherwise, what does the moment try to do? When I was explaining bending moment, I said the moment has a tendency to rotate the beam. Am I right, beta? Correct? Am I right, class?
Yes, sir.
The moment has a tendency to rotate the beam. Let me just put on the camera for 5-10 seconds. Okay, I'm sure it is visible now. Okay, now guys, you see, if I have a cantilever, let us say I have a cantilever, let us say this now, I support it only at one end, the tip of my pen. Okay, I have held it here like this. Now this is the beam. Supported at how many points? At one point, singular point. Now guys, there will be some forces upward, downwards, which are acting on the beam. Now these forces, if they have a residual bending moment, either clockwise or anti-clockwise, if there is a net bending moment, what will it do? It will tend to rotate the beam about this point. Yes or no, beta? Even if I have held this point, the beam can still rotate about this point. Yes or no, beta? Am I right? Unless I strongly hold like this. Yes or no, correct? Correct?
Yes, sir.
So if there is a moment, if there is a resultant moment about the free end, then the beam cannot be in static equilibrium. And if the beam is in static equilibrium, that means the resultant BM at the free ends needs to be definitely zero. And this is the point people were missing out. Okay. So what is a cantilever? I'm putting off the camera. What is a cantilever? Cantilever is a beam supported at a singular point. Like you see the balcony of your house. I'll clear this, whatever is written here, and use this space to explain. Okay. You have the balcony of your house. You have a wall. You have the roof on this side, and then you have projection. This is your balcony. This is a cantilever. It is supported at one point. You must have seen doing what? If there is a wall or something, they put a pipe in it. Now the pipe, this end is fixed. This is called a cantilever. Why? Because whether it is the balcony of your house or this particular beam, they are supported at one point. And in cantilevers, usually, I'm not saying there's a hard and fast rule, but usually in cantilevers, the support is at the end points. I have not said always, I've said usually. Okay. Now, the beam in each case, this beam can be uniform cross-section beam, or it can be light beam. And this beam can carry weights on it or forces on it, which can be UDL or which may be single point. And this is what is called as the cantilever. In a cantilever, the end which is free, which is floating freely, is called as the free end. And the end which is fixed or supported is called supported end or fixed end, whatever you want to call it. So the end of the or the point where the cantilever is supported is called as the supported end, if it is supported at the ends, right? And the other one is called as the free end. Now guys, so in a cantilever, unlike a normal beam, how many free ends are there then? There is only one free end. The beams you have studied until now, they had two free ends in each case. Yes or no, beta? Am I right?
Correct.
Yes.
Sir.
In this case of cantilever, there will be only one free end. Now, please remember that BM at the free end has to be 0. And if you keep following, otherwise it is like beam only. Everything is like beam. But if you keep following blindly the beam concept, then in some cases, not always, in some cases, you may end up hitting a maximum BM at the free end. In fact, I'll show you a WhatsApp which I received only yesterday. Yesterday or day before yesterday, let me just show you. And this is the problem that persists in the system here. I'll just show you here. You can see when yeah, this message is for which date? You can see better. This message is for Saturday. Okay. And what does the message read? Read it here. Can you read the message? It's on display.
Yes, sir.
Okay. And what was my response? I can show you that also. This was my response. So I hope you will, if you have studied differently, please disregard that. That is my suggestion to you. The rest I can't comment beyond a point. Okay, if there is a issue, then there is a issue. So this is the type of confusion which keeps happening. Anyway, now I'll take the question straight away. Some of you may have seen the video. Those who have not seen, please see that. You can see as many times as you want to see. This is one of the questions we had skipped. Now, guys, sometimes the question may say that the left end of the cantilever is supported, or sometimes they may say the right end is supported. If the question specifies which end is supported, then you'll have to be bound by the question. You cannot then take the liberty. If the question does not say which end is supported, like in this one, is just saying it's a cantilever and supported, obviously, and he's not said it is supported at the end. That means it is now, he's not explicitly said in this question that it is supported at the end. But since it's cantilever and it has a free end, that means the other end is supported. It is implied here. So don't again start looking for, sir, fixed word was not there. How do I know it was fixed at the end only? So if it is missing in this question, it is implied that it is supported at the end. Okay. Now, guys, you don't have to do it both ways. You don't have to support at both the ends. I will do it both ways, as I have done in the video, just to tell you that if in some cases you may have to be careful, because when you make the BM table, there is no change in the SF. SF continues the way it was for the beam. In fact, SF becomes easier because there is no calculation of reaction required. Entire reaction acts at the support. Okay. When it comes to BM, please remember, BM will be calculated from free end to fixed end, which may not be from left to right every time. And I've already told you, if you're reversing the direction from right to left, yesterday in the 2.55 meter point question also it came up. If you happen to go from right to left, then positive SF area will give you which BM? Negative BM, and negative SF will give you positive BM. If you go from left to right, it continues to, there's no change. Positive will give positive, negative will give negative. So I'll do this question with both the methods. I know it will take a little more time, but it's okay. And guys, I'll support both the ways. You can do in the exam either way. Don't say, sir, this is easier. That's up to you what you want to do. Because you cannot say this is easier. I will shut myself out from the second one, because tomorrow in the exam he says which end is supported. Then you are bound. You don't have the choice. Okay. So let me have the left end supported one first. A cantilever is 6 meters long, carries a concentrated load of 45 kilonewton at its free end. Is not given whether it has its own weight, so it will be a light beam cantilever. So first I'm making a left end supported cantilever. This is the wall or the support, you can say, beta. This is the cantilever. Length is 6 meters. It carries a concentrated load of, so let's say this is A, this is B. It carries a concentrated load of 45 kilonewton at its free end and also a UDL of 20 kilonewton per meter. It carries a UDL of 20 kilonewtons per meter like this here.
Over a length.
So 20 kilonewton per meter over 6 meters means total of 120 kilonewton.
Yes, sir.
Okay, and 45 kilonewton is the weight here. So guys, there is a total downward force of 165 Newton. This reaction will act at A. RA will be equal to 165 kilonewton. No calculation for reaction is required. Guys, if you treat it as a beam, how many points minimum you are required to get the SF diagram better? How many minimum points?
2, sir, 2.
2. So I'll make the SF table for A and B only. In this, A is a free end, fixed end, and B is the free end. Guys, from left to right, it is A and B. SF in this case will be kilonewton. Guys, any of them required to be divided into 2? Tell me, A or B? Any or both?
Both, sir, both.
Why? Because both are
B, sir.
concentrated. A also, beta, this reaction is concentrated, na beta?
Okay,
Understood?
understood.
इसका मतलब वीडियो नहीं देखा, कोई बात नहीं, ठीक है? To the left of A, the shearing force will be 0. When I come to just right of A, plus 165 comes into picture like the beam, and you have this shearing force. I carry forward plus 165. And from A to B, what is the change taking place, guys? Minus 120 kilonewton, correct? Am I right? And you are left with plus 45 just to the left of B. You carry forward plus 45, and then you just, as you go to the right of B, it becomes 0. Does everybody agree with this SF table? Yes or no, class?
Yes, sir.
Similar question has been solved with some value changes in the video. But I took the values from MMD question so that now we make the SF diagram. I draw it here in line with the fixed thing. It is all plus, so I don't have to have anything below it. I have A, I have B, I have shearing force in kilonewton, 40, 80, 120, 160. It is 0 at A, so let me just change the color. If anybody does not understand, please interject. It is simple beam concept we are following. It's 0 to plus 165. So here it is plus 165. Then it comes down to plus 45 and becomes 0. Now I have to join plus 165 to 145. I go to the cantilever diagram. The change from 165 to 45 is because of the UDL. And UDL by name is uniformly distributed, so it's changing at a uniform rate. And therefore, these 2 points are joined by a straight line. This is the shearing force diagram for this question. Correct, beta? Am I right?
Yes, sir.
Okay. How many points minimum do I need for the BM, beta? BM table.
2, sir, 2.
Minimum 2, right? You want to take more, it's your choice. So I make BM table by areas under 2 things, by areas. First is from free end to fixed end. Why? Because the BM at the free end has to be 0. BM at the free end has to be 0. So from free end to fixed end, number 1 and 2 by areas under SF diagram. So we'll make the BM table from free end to fixed end. Which end is free end in this, A or B, guys?
B.
B. So I'll make the BM diagram from free to fixed, from B to A. And my BM will be in kilonewton meter. Now cover your thing to the right. Now from when I'm coming from B to A, am I coming from right to left or left to right?
Right to left.
Right to left.
Right to left.
Right to left. So cover is to the right of B. Is there any bending moment?
No, sir.
No, sir.
0. I carry forward this 0 and I then uncover up to A. So I have gone from right to left. The positive shearing force area will give me what, BM, guys? Positive or negative?
Negative.
Negative, sir.
Negative, sir.
So it will be minus this, whatever area comes. Area of trapezium is half into sum of the parallel sides, 45 plus 165, into the distance between them, 6 meters. Correct? So how much do you get, guys? Minus how much?
630, sir. 630.
Minus
630.
630. Have you understood why it has become minus, guys? This we had already discussed earlier. So there is no goalpost shifting. We are sticking to exactly what we learned, right? Am I right? Is that clear, class? Better mute kar lo if you're talking to each other, please. So guys, in this case, how will be my BM diagram? Now, when it comes to making this, I draw the y-axis in line with the fixed end A. Here is my B. So this is A, this is B. And this is minus 630 here, and it is 0 at B. Guys, that's a trapezium from B to A. Is it from smaller side to bigger side or bigger side to smaller side?
Smaller to bigger.
So it will be more like a vertex to base. Am I right, guys? Something typically like that, right? Yes or no? Why?
Yes.
Because this comprises of a rectangle and a triangle from vertex to base. So the curve or the BM diagram of this question would be somewhat like this. Is that clear to everybody, guys? What they were doing is they were going in the BM also from left to right, and what they were doing is they were coming plus 630 kilonewton meter BM at end B. Now, if there is a BM about end B, the beam cannot be in static equilibrium. She should be rotating about point B. So therefore, please see that in bending in cantilever, the bending moment will be always from free end to fixed end, and at free end, the bending moment will always be 0. Is that clear, beta? Am I right? Class, is it clear?
Yes, sir.
Yes, sir.
Now, just for the sake of clarity, I don't have to do the other one. Let me do the other one also. Suppose somebody draws supporting the right hand. That means he'll draw the cantilever like this. Now I'll name the same way. Fixed end I'm naming A and fixed end at B. Now you have a UDL here of 120 kilonewton at the rate of 20 kilonewton per meter, and at free end you have 45 kilonewton. Guys, tell me, is there any difference in this cantilever and this cantilever technically? No, only the ends have changed. Otherwise, so don't you think that whatever is the whatever is the SF at B here should be the SF at B here. Whatever is the BM at B here, that should be the BM at B here. Yes or no? Am I right, beta? Correct? Because B is the free end in both the cases, correct? It's the same cantilever, correct, guys? Whether you support the left or right, does it change the stresses or the stresses on it? Bending moment and shearing force, will it change?
No, sir.
No, sir.
So that is the test of what I'm saying is being correct. Now we'll do the way we have done. So now the reaction will act at A. How much? 165 kilonewton. We'll make the SF table. We'll make from left to right. Right. On the left, I have point B, and then I have point A. SF will be in kilonewton. What is the SF? They will be divided into two parts. How much is the SF just to the left of B, guys? Look at the diagram and tell me.
0.
0. What is the change from just to the left of B to right of B? What is the change? Minus 45. Very good. When you go from left to right, upward is positive, downward is negative. You carry minus 45. What is the change from right of B to left of A? Minus 120, making it minus 165. You carry forward minus 165, then you have RA of plus 165 becoming 0. So you see, at fixed end and at A, the shearing force was 0 and it changed to minus 165. And I'll now draw this. Let me make the shearing force diagram, and then I'll tell you that whatever in kilonewton, it is the same thing. Only the sign has changed. Why? Because our point of reaction has shifted from left to right, but values will be unchanged. Shearing force in kilonewton. Oh, I have to make the diagram now. Okay, let me make the diagram here. We have minus, so let me just take it like this. We have B here, we have A here. Let me change to green so that the table red does not distract you. Okay. This is 0 at here to minus 45. And then you have minus 165 and 0. And obviously, they will be joined with a straight line. What do you see, guys? You see, what was the shearing force in this diagram at B? It was 0 to plus 45. What is here? 0 to minus 45. Values are same. Only signs have changed. Why have they changed? Because in this case, it was the positive force was acting on the left side. In this case, the positive force is acting to the right. But value of the shearing force at the free end is same. 0 to 45, 0 to 45, notwithstanding that on one side it was plus, on one side it was minus. So remember, if two of you have supported different ends, you will get the same values of the SF, but one will get the diagram above the x-axis, other will get below the x-axis, so don't get confused. At fixed end, it was 0 to plus 165, it is 0 to 165 here. So values are same. Why there is a reversal of sign? Because the positive force has changed its place from left to right or right to left. But the BM will come exactly the same. Let's see now. Let's make the BM table. From what? 1, free end, free to fixed end, and 2 by areas under SF diagram. In this right hand side diagram, which end is free, guys? Which end is free? B
Left
is
one.
free. And yeah, so we are going from left to right, correct? So
Yes,
BM will be kilonewton meter B to A, fixed left to right. What will be the BM to the left at B? 0. Okay. Look at this BM SF diagram. What will be the change from B to A? Now we are going from left to right. So negative area, this negative SF area will give you positive BM or negative BM?
Positive BM.
Positive.
When you're going from left to right. Now you are going in this diagram from left to right, my friend.
Negative BM.
This will give you negative BM because you're going in this diagram, you came from right to left. This was right to left. Here you're going from left to right, correct? Yes or no? Correct, class?
Yes, sir. Correct.
So now it will be minus half into sum of the parallel sides into 6. It will be minus 630. So you see the BM comes exactly the same. At free end, it was 0 here. It is 0 here. At fixed end, it is minus 630. It is minus 630. Now you'll say, sir, why it is not 0 at fixed end? Fixed end is not a free end, my friend. The fixture of the end does not allow the beam to rotate. So, and another example I'll give you guys. If you put a pipe like this in a wall, now whether you hang yourself here or you hang yourself here, where does the pipe bend? Does it bend at A? Does it bend at any B, or does it bend at any point in between? Where does the pipe bend when you put weight anywhere? Where would the pipe bend?
B.
B. Pipe bends at
A.
B.
A.
Just imagine if you have put a pipe and you are hanging to it, where does the pipe bend?
Free end.
A.
Array, free end pe it does not bend. Free end moves up and down, but bending takes place here. If this bends, it will bend like this, correct? So bending is taking place here. The free end is moving up and down, correct? Because of the bending.
Yes, sir. Correct, sir. Correct.
The bending is taking place at the fixed end, correct, beta? Why?
Yes, sir.
Because the fixed end has the maximum bending moment. Fixed end has the maximum bending moment in cantilever, correct, beta?
Yes, sir.
Am I clear, class? So whether you support left hand or right hand, the answer of the shearing force will be same. Only thing is, in one case, the shearing force diagram will be above the x-axis. In the other case, it will be below the x-axis, but the shape of the diagram will be same. But BM diagram for both the cases, whether left hand or right hand, BM will come the same. You see, this is the fixed end. I calibrate the axis here. This fixed end is A, free end is B. It is 0 at B and minus 630 here. And the shape is exactly the same. Both the shapes are same. Am I right, guys? Have you understood, class? I'm sure those of you who have cared to see the video, they must be more comfortable because the same thing was spoken there, what I have spoken in the class. Am I right?
Yes, sir.
Okay. So this is how you'll handle the cantilever. But problem here is with MMD is people teach wrong and then they start making questions more complicated because they start picking up questions from here and there. Guys, there was a time when such cantilever questions, simple cantilever like this, when it used to come in the exam, there used to be hue and cry that it is out of syllabus. And sometimes people used to change the question also. But now the present day trend is that they don't stop at this type of simple cantilever also. Now I'll take you through to some different types of questions which have come in the MMD, which are not where the word cantilever is not used. But if you look at the question, it will translate into a cantilever. And it is very important for you to identify such cases. Guys, I'm shifting to the next question unless anybody has a doubt. Please let me know. Okay. Then came a question in the MMD exams in April 21. Now, again, why do the boys get confused? Because the question is not you saying cantilever. What does it say? There is a uniform log AB 10 meter long. So log can be beam weighing 100 kilonewton. It has supported at a point 2 meters from end A. And that's all. You remain silent now. It also carries a point load of 30 kilonewton at end B. Draw SF and BM diagram of the beam stating their values at intervals of 2 meters. I don't have it digitized. Let me see. Is it digitized? No, it is not digitized. So I'll do it back. Okay. Now you see, guys, it's a single point support. Do you agree with me? It's a single point support, guys. Yes or no?
Yes.
Now, a beam cannot be supported at a single point unless that point gets fixed in a wall. That means this can remain. This can be like this only if this is the log of the wood, guys, of uniform cross section AB. It's 10 meters long, and he says it's 100 newtons, 100 kilonewton at the rate of 10 kilonewton per meter. And he says it is supported at a point 2 meters from end A. It is supported at where is the cursor here? Right here. It is supported at a point 2 meters from end A. So that means it is supported somewhere here. Now the beam can be in equilibrium only when it is fixed in a structure like a wall or something. Yes or no, beta? Otherwise, beam cannot remain in static equilibrium. Do you agree with me? Yes or no?
Yes, sir.
Yes, sir.
So what does it form now? It forms a cantilever, right? It forms a cantilever, correct? Correct, guys?
Yes, sir.
And it carries a point load of 30 kilonewton here at end B. This is what the question says. Guys, read the question and do you agree with the diagram first? Tell me. The question does not use the word cantilever. Now, if a student does not have exposure to the proper concept of it, he'll go for a complete spin. Guys, tell me, can I support a beam like this with 30 kilonewton here? Can I put a support here and support it? Can it remain supported?
No, sir.
No.
It will rotate like this and topple.
Yes, sir.
It will rotate like this and topple. So it has to be supported like this. Am I right, guys? Anybody has any questions on the diagram, guys, before we discuss further? Okay. Let's say this support is X. Guys, he wants to take point every 2 meters. If you want to take 2 meters every 2 meters on the diagram, I have no issues. But I want to save on time in the class, so I'll just do with minimum points. But if somebody wants to take more points every 2 meters, you by all means you can take it. No problems. Okay. Guys, how much will be the reaction at X? Can you tell me? Which will act upwards? What will be the reaction at X?
Sir, 130 kilonewtons.
130 kilonewtons, right? If it was a simple beam and disregard 2 meters thing, how many minimum points for SF table, guys?
2.
Only two? Only two? What was the criteria told to you, beta?
3.
So 3.
Why are you forgetting the criteria, the rules which were given to you? Now from 2 it has become 3. So there will be minimum 3 points, end points, and where there are additionally point forces, right? Correct. So we'll have 3 points, A, X, and B. These are minimum. If you want to take every 2 meters, naturally number of points will increase. Okay, guys?
Sir, but if they asked in exam, we have to do it 2 meters, right?
He wants value. You can give the value at the end, or you can take every 2 meters. Choice is yours, right, beta?
Okay, sir.
But you must close out the question as required, right?
Okay.
So if you want to give at the end, that is up to you. If you want to calculate every 2 hours and facilitate drawing of the curve, then you can take every 2 meters, no issues. Okay. I would suggest in such a simple case, it will only increase 2-3 points. Take every 2 meters, right? That's my
Yes.
suggestion.
Okay.
Now, guys, where all do we have, which all cells do we need to divide, if at all? We have to
X and B.
X and B. What is the shearing force at A? 0. I carry 0 here. From A to left of X, we have 2 meters of the weight of the beam. So minus 20. So shearing force becomes minus 20. Does everybody agree? To the left of X? Yes or no?
Yes.
Yes.
Yes, sir.
When I jump just to the right of X, plus 130 comes into picture. It becomes plus 110. Am I right, guys?
Yes, sir.
Yes.
Then I carry forward plus 110. What do I apply? What is the change from right of X to left of B, guys? What is the change? Look at the diagram.
8 into 10.
Minus 80.
Weight of 8 meters of the beam.
Minus 80.
Minus 80. Leaves plus 30. I carry forward plus 30. Then minus 30, making it 0. Does everybody agree with the SF table, or anybody has any questions?
Agree, sir.
Okay. Guys, it is only my suggestion. When you draw y-axis in such cases, what is the purpose of y-axis? Y-axis is only for scaling, na? Yes or no? Whether y-axis is drawn on the left side, right side, somewhere in between, does it make a difference? Y-axis is only for scaling, correct, beta? Am I right? Guys, y-axis in the drawing is only for the scaling of the SF or BM as the case be, correct? Where the y-axis is drawn, does it make a difference? Tell me. In the previous question here, if I had drawn the y-axis instead of here, had I drawn the y-axis here, and still the diagram would have come like this, does it make any difference? Yes or no? If this is plus 165.
No.
It is only for scaling, correct? Do you agree with me?
Agree, sir, agree.
Where the axis is drawn is immaterial. So what is my suggestion to you? To make it simple for yourself, it's a suggestion. Draw the y-axis in line with the support, or where you have the maximum SF. So where is the support? Support is here. So that is my suggestion. Rest is up to you. This is the thing. We have, it goes to minus 20 and plus 110. So we have some of it going. So this is the beam here. This is A. This is X. This is B. Let me change to red marker. You will scale the y-axis. You will have SF on this in kilonewton. And now it is 0 at A. This is 2 meters. Then it becomes minus 20 at X. Then it becomes plus 110 here. Then it becomes plus 30 here. And then it becomes 0 here. Guys, look at the diagram. From A to X, is the change from 0 to minus 20 at a uniform rate? Yes or no?
Yes, sir, uniform.
Yes, sir.
So this will be joined with a straight line. Likewise, from right of X 110 to plus 30, is it changing at a uniform rate? Yes. Why? Because of the weight of the beam. So we join them with a straight line. Does this become the SF diagram of this question? Yes or no, beta? Tell me. Does this become the SF diagram?
Yes, sir.
Yes, sir.
Now, if you had taken now somebody says I would have loved to take at 2 points, 2 more points. So it is 8 meters on the other side. So 2, 4, 6, 8. Let's say you would have said P, Q, R. How much will be here, here, and here? You can find out straight here. कोई ऐसा issue नहीं है. It is changing what? It is changing at a rate of 20 kilonewton. So this will be plus 90. This will be plus 70. This will be plus 50. Right, guys? Yes or no? 110 to 90, 90 to 70, 70 to 50, and 50 to 30. Correct?
Yes.
Am
sir.
I right? And now
Right, sir.
every span is 2 meters. So if you take more points, it's up to you. I have no issues. Now let's take all these points for BM. Let me take all the points, no problem. Let me take 1, 2, 3, 4, 5, 6 points for BM. But guys, in this, the beam is a cantilever beam because it is supported at a singular point. And how many free ends are there now?
Only one.
Only one free end.
Two.
2. That means at about both A and B, the BM should be 0. Correct? Yes or no?
Yes, sir.
So BM table from fixed, free to fixed, and 2 by areas under SF diagram. Now I can make 2 distinct tables. Now guys, if I go now, don't do this on the diagram. When I go from A to X, it is left to right. Am I right, beta? Because A is a free end. Correct?
Correct, sir.
When I come from B free end to X, I'm coming from right to left. So be wary of the sign convention. So now, how do I make the table? You can make one table here like this. The table can be made in different forms, guys. There's no hard and fast rule. One I can make like this. BM in kilonewton meter, A to X. Why? Because this is free end to fixed end. The second one I can make like this. If I want 1, 2, 3, 4, 5 points, and you will see logic by yourself. You can change the format if you want. There's absolutely no problem. So 1, 2, 3, 4, and 5. And now we want to go from free end to fixed end. So since X was there, I'm continuing like this. This is how I feel it comfortable, but you can always change. And I'll be filling it up like this. Have you understood what I'm saying? Is that clear, beta? You can put arrows like this if you want. No problem. I'm sure filling up from A to X is not an issue. What will be the shearing force at what will be the bending moment at A, guys? Look at the SF diagram.
0.
0.
I carry forward 0. What is the change from A to X? Will it be minus
20.
or plus? Will it be minus or plus?
Minus.
Very good.
Minus
Minus.
20.
Very good. So minus half into 2 into 20. It is minus 20. Very good. Now we have to come from right to left. What will be the bending moment at B, guys?
0.
Pay attention. Now we are going from right to left. I carry forward this 0. What will be the change from B to R? Will it be plus or minus?
Minus.
Minus.
And which area? Area of this trapezium, correct?
Trapezium. Yes.
So minus half into sum of the parallel sides, 50 plus
30 into
80 into 2. So it is minus 80. Am I right, guys? Correct? I carry forward this minus 80. What is the change from R to Q? Again, minus, and this trapezium. Minus half into 70 plus 50 is 120 into 2. So it is minus 200. Am I right, guys? Yes or no? Does everybody agree, class? Please confirm.
Yes, sir.
Then we carry forward this minus 200, and then we have this trapezium. Minus half into 90 plus 70, 160 into 2. So minus 360. Then we carry forward minus 360 and we'll have this last trapezium minus
-200.
half into 200 into 2 minus 560. Am I right, guys? Yes or no?
Yes, sir, minus 560.
Does this table forming like this makes much easier and putting the arrows on top which guide you which way you need to fill that up? Yes or no, beta? If you follow it, it will be relatively easier. Now we'll make the BM diagram. As I have already suggested you, I strongly recommend that you make the y-axis in line with the support. Okay. Now I have all minus, so there is no reason for me to have anything above this. So I have A, I have X, I have P, I have Q, I have R, I have B. 560, so let's say 100, 200, 300, 400, 500, 600, minus 600. It is 0 at A and it's minus 20 here. It's a triangle from vertex to base, so it will be joined like this, somewhat like this. Am I right, guys? Let me change to green marker so that it does not confuse you. Will this A2X be like this, guys? Up to minus 20? Yes or no? Am I right?
Yes, sir.
Then it is 0 at B. It is minus 80 at R. It's minus 200 at P. It's minus 360, 1, 2, 3, 360 at this. And it's minus 560 here. This will be the bending moment diagram here. And if you want, you can join here. Doesn't matter, because this support is converting this into two distinct cantilevers. It's dividing the log and making it in two distinct cantilevers. Correct, beta? Yes or no? Am I right?
Yes, sir.
This will be the BM diagram. This is a curve, guys. This is not a straight line. So this is the BM diagram as per my understanding of this question. Why they have started putting these questions, I have no answer to it, unfortunately. But this is a MMD April 21. I often say that maybe somebody's son is doing engineering and he would have got hold of his engineering book or something and he copied the question. That's all I can say. If you want to take the screenshot or something, please do that. And also evaluate over next 10 seconds if you have any questions on it. Shall I go to, yeah, tell me.
For this BM, do we need to take so many points, or can we take directly like how you were doing?
No, but no. Why I took was because he wanted BM at every 2 meters. If you start reading from the curve and I would have drawn with 2, but then getting these values, and if you read from the curve, there would be unnecessary errors, right?
Okay, sir.
Whereas SF was a straight line, so we could just get the values correctly, right, by calculation. The question is saying that he wants the SF-BM diagrams every 2 meters, right?
Yes, sir.
Okay, that's why. Otherwise, you could have drawn with B and X also only, the way we had done in the last question, right, Samuel?
Okay, sir.
Okay. So earlier, they were contesting whether cantilever is part of the syllabus or not. Then a simple cantilever like the previous question became a routine. Then once that became a routine, somebody came with this question. And when people did not object to this question also, then in 23, they went totally overboard. And they came with this question, which I have digitized. Read this question. It's a November 23 PM batch. Some of you may have seen it, I don't know. Read the question, don't focus on the solution, guys. He says a uniform log of log AB, 15 meters long, weighs 150 kilonewton. It is supported at midpoint by a 3-meter platform. It also carries a point load of 45 kilonewton at end B. Draw the SFBM diagram stating their values at every 3 meters interval. Guys, I have done it two ways. I have shifted the 45 kilonewton to left hand also to show that it is a cantilever, and that's how the values will come same. But you have to do this way. This is what the question of the MMD says. This is as per the question. The left side solution is as per the question. Okay. I'll send you this solution. Please try to understand it. Don't unnecessarily try to take it down. Firstly, can you read the question and confirm if you agree with the beam diagram? Please read the question and tell me. Do only focus on this diagram and tell me if you agree with the beam diagram. It is as if somewhere in the middle of the beam, it is rested on a surface. And now you have 45 kilonewton put on this side. That means the beam is reasonably heavy and it is not toppling. It is not rotating. It is in static equilibrium. Because if it topples, then it does not. The question makes no sense. Does everybody agree with the beam diagram, guys? Can you correlate the question and the diagram? Please tell me. If anybody has only focus your question up to this place, up to this diagram. Guys, last call for any doubts in the diagram. Do you agree?
Yes, sir.
I'm not doing the right side one. Right side you can see in the solution that I'll send. I'll only do the one which is strictly as per MMD question. Guys, then he wants every 3 meters. So I could have skipped C. I could have skipped D. Because as per the beam, end points are must. Point force is must. And where UDL, uniform forces are changing, X and Y were must. I could have at the most skipped C and D, but I have taken them because the question says take them at every 3 meters. Okay. Otherwise, we could have saved on 2 points C and D. Other points still would have been required. Am I clear, class? Yes or no?
Yes, sir.
Guys, then do you agree with the reaction calculation that it will be uniformly distributed over 3 meters, class? 195 kilonewton
Yes, sir.
total reaction, 65 kilonewton per meter. Guys, there is only 1 point force, so last cell is divided into 2. No other cell is requires division. Do you agree with me? Only point B requires division, right? Yes
Correct,
or
sir.
no? Now let's together start from left. At A, the shearing force is 0. Does everybody agree? Yes or no?
Yes, sir.
Yes, sir.
We carry forward 0. Look at the beam diagram. What is the change from A to C? Is the weight of 3 meters of the beam. That means minus 30. At C, the shearing force becomes minus 30. Am I right? Correct?
Yes, sir.
Then we carry forward minus 30. What is the change from C to X? Another weight of 3 meters, minus 30 becomes minus 60 at X. Correct, beta? Yes or no?
Yes, sir.
We carry forward minus 60. Now pay attention. There are two forces coming between X and Y. One is 3 meters of the weight of the beam, that is minus 30. And 195 kilonewton of reaction coming into picture, making it plus 105. Does everybody agree? Please review the entries in under point Y.
Agree, sir.
Okay. Then we carry forward plus 105. From Y to D is minus 30. Then carry forward plus 75. From D to left of B is minus 30 plus 45. And the moment I go to just right of B, it becomes 0. Does everybody agree with the filling up of the SF table? Tell me, guys.
Yes, sir.
Yes, sir.
And when we plot this, does this come as the diagram, SF diagram? Please review it. You can review on the screen only. You can practice it later on. Will this be the SF diagram?
Yes, sir.
All joined by straight lines. And can you now calculate X, Z and ZY the way we learned? The change is 1765 units over 3 meters. So what will be XZ and what will be ZY? Do they come what is written in the diagram here? Yes or no? Please calculate XZ and ZY. You already know how to calculate them. Clear, class?
Clear, sir, clear.
So that is the SF diagram for this question. Now, in the BM diagram, which will follow now, we'll do by areas under the SF diagram. Now, guys, how many free ends are there for this beam?
2.
2 free ends. Now you see, you can clearly see this area 1 and area 2 are not equal. So if you just keep adding areas, BM at B will not become 0. Do you agree with me? Yes or no? Area 2 is clearly much greater than area 1. Yes or no?
Yes, sir.
So if you keep adding, going from left to right, add areas under the SF diagram, they will not become, BM will not become 0 at B. And if BM does not become 0 at B, then beam cannot be in static equilibrium. Do you agree? Yes or no?
Yes,
Yes.
sir.
Correct, sir.
So therefore, this side is tending to bend this part and this side is tending to bend this part. That's how the beam is in static equilibrium. And where will be the maximum bending moment? At Z. Because it is here that it is cutting the x-axis. So this becomes again like two cantilevers because BM at A and B has to be 0. That means when I calculate BM, I'll calculate like this up to Z. And when I calculate BM, I'll calculate up to Z like this. Have you understood what I'm saying, guys, before we go to the BM part? Yes or no? Clear, guys?
सर एक बार प्लीज समझा दीजिए I did not.
क्या नहीं समझ में आया बताओ क्या समझ में नहीं आया you tell me.
Sir, earlier you were saying that BM 0 नहीं आएगा because उसका जो area above the axis है and below the axis है वो it's not similar. I understand. आपने
हाँ.
Z पे एक axis बना दिया. But the
No,
thing
red
is
पे
that
तो red की axis को छोड़ दो अभी थोड़ी देर. So
हाँ.
then what does it mean? That means B is a free end. अगर वहाँ BM 0 नहीं होगा तो beam cannot remain stationary the way it is drawn in the diagram. Yes or no?
Yes, sir. I understand. Yeah.
So that means it is basically resulting into two cantilevers, right? Two free ends.
Yes, sir.
It is not supported at one point, but it is behaving like two cantilevers, correct?
Correct, sir. Correct.
The right side is tending to bend about somewhere here, and left side is also tending to bend somewhere here. Where will be the maximum bending moment? That will be the point Z here. Why? Because maximum negative area will be here, and this area will be also maximum here. Yes or no? Where it is crossing the x-axis.
Yes, sir.
Guys, am I clear before I go to calculation of BM? You need to appreciate here that it is not a fixed end. There is no technically a cantilever form, but this beam will behave like a cantilever per force. Otherwise, this beam cannot remain like this. It will topple this side or that side. It cannot, then the question makes no sense. Am I clear? Suppose there is a resultant bending moment at B. What will happen? This will basically drop the beam this way. The beam cannot remain like this. Am I right, guys? Yes or no? Have you understood what I'm saying, class?
Yes, sir.
Yes, sir.
What was the logic of this question? I can't answer that, unfortunately. I have to do the solution of this question that I can logically tell you. That's all. Then now, this is the SF diagram I brought from the previous sheet. Now, since we had taken so many points, I have calculated these areas separately. This is the area of this triangle. This is the area of this trapezium. This is the area of this triangle, just so that my table does not get cluttered. And I have calculated these areas. This is area of a triangle. This is trapezium. This is trapezium. This is A3 is triangle. A2 is trapezium. A1 is a triangle. Can you see the calculation of these areas? Just see how it has been calculated. Not to worry about the values. Correct, Peter? Is that clear, class?
Yes, sir.
Okay. Now, that means you see now, I'm making the BM table by areas under the SF diagram from two free ends to the point of maximum BM Z. So one I'm making from A to Z, in which we'll be moving left to right. When we go from left to right, negative SF will give negative BM, positive SF will give positive BM. When we move from B to Z, we are moving from right to left. Positive SF will give negative BM, negative SF will give positive BM. So whatever we did in the previous question, the same thing is repeated here. Can you see the BM table now, guys? A to Z, you can see my arrows, and B to Z. Please see. Please see if everybody is in agreement with the BM table. If you have any clarifications to seek, please do so. Guys, last 10 seconds for doubts on the calculation or completing of this table. Please let me know. No question, doubts? Then we make the diagram. Can you see also the BM diagram below it? What have I done to make the diagram easy? To make the diagram easy, what I have done is, in line with Z, I have taken the y-axis. As I said, I can take the y-axis wherever it suits me the most. So what have I done? I have taken the y-axis here. So do you agree with the diagram? If you're okay with the table, then diagram is just a representation of the table into a graphical form, right? If you have a problem,
Yes.
that should be with the table, not with the diagram actually. Correct, guys? Sometimes people ask me, sir, should we join it? You join them, there's no harm. You don't join them, it's okay, no problem, but you can join them. So basically, somewhere around Z, the beam will experience bending moments like this. Whether it will bend or not, that again will depend on the strength of the beam, guys. I don't know why this question is here. Please don't ask that question to me. But if it comes, this is the way you'll have to attempt it. Most of our boys had done it right when it came first time, because they treated both the ends as free ends. They treated both ends as free ends, since it was emphasized adequately that BM at three ends has to be 0. So they kept that in mind and they were able to close it out. So guys, with this, I come to end of cantilever thing. These questions, this question is not in the list. So you can, I have shared the, can you see, have you received the solution to this question, guys? Just check.
Yes, sir.
You have to do only one side of it, not both the sides, guys. The other side, I've just shown that you see in the other side also you get the same diagrams, but it doesn't matter. The left side is the one strictly as per the question, not the right side. Okay. Guys, it's 10:59. Just take a short 6 minutes break. 11:05. We continue. I take the doubt on the question, homework question also, and then we start with the box-shaped vessel. And 11:05, we resume the class. Is that okay, beta?
Yes, sir.
Somebody said he would like to compare. This was the question I had given you as homework yesterday. A beam of uniform cross section, 40 meter long, weighing 320 tons, is resting completely on a plane surface. It carries a UDL of 200 tons each over 10 meters of its length at the ends, and an UDL of 800 tons over 20 meters of its mid length. Draw the SF and the BM diagram of the beam. Guys, I'm sure those of you who have done this question would have drawn the beam of uniform cross section. You can name it whichever way you want. Okay, it is 320 tons, so length is 40 meters, weight is 320 tons at the rate of 8 tons per meter. It is resting completely on a plane surface like this. And then it carries certain UDLs, 200 tons each, UDL of 200 tons each, over 10 meters of length. So if I divide into 4 parts, each section will be 10 meters. So there is a UDL of 200 tons here at the rate of 20 tons per meter. There will be a UDL of, this is all based on what we know, we have learned earlier. This is 200 tons at the rate of 20 tons per meter. And then there is a UDL of 800 tons over this length at the rate of 40 tons per meter. Is this the diagram you made for the beam, guys? Yes or no? First tell me that.
Yes, sir.
Okay. Now, what is the total reaction? Beam is 800 tons, 320 plus all this. What reaction is? 1520 tons. Since it's resting completely, it will be uniformly acting over 40 meters. If we divide by 40, it is 38 tons per meter.
38.
Okay. Okay, fine. So Amit, you wanted to compare, or was it somebody else who wanted to discuss this question? Was it you or Ali? Who was there?
Sir, me, sir, Akash.
Akash, okay. Is that okay? Okay. Now,
Yes,
guys.
sir.
Now, look at this diagram. How many minimum points you think we need in this case for the SF diagram? Use your concept of beam. How many minimum points? How many minimum points, class? Tell me.
4.
Minimum 4.
4.
7. Which minimum 7, beta? Can you tell me which 7? But just the 7 bola, don't eat into everybody's class. Please respond when you are being asked which 7. If you have counted 7, please tell me which 7 are you talking about?
Sir, point A and then reaction point, and then
Which is
end of this.
which is the reaction point?
Sir, middle of UDL.
Why? Reaction is uniformly distributed. Why it should be middle? Why should it be middle? Akshay, why should it be middle? Can you tell me one of the reasons?
Sir, understood, sir. Like in previous questions,
So that means you never bothered to do this question yesterday, correct, Akshay?
Sir, this question I didn't do yesterday.
So you should have done it, no? But if homework is given, it is given with some intent, no? Then you would have come better prepared with your doubts.
Yes, sir. Correct.
Earlier question, what did we do? Did we change the goalpost? No. What did we do in the earlier question? Tell me.
Sir, in the earlier questions, we were taking the center point of the UDL.
For what purpose? For what purpose?
Because sir,
for
reaction.
SF. But reaction calculate karni hai isme. Is reaction?
Nahin,
is
sir.
reaction? So then what is why do you need to take what was my question? My question is how many minimum points for SF? You said 7.
Yes, sir.
So which 7 points for S?
Sir, वो समझ गया सर गलती.
Okay, guys, how many minimum points?
4.
4. Very good. 4. The two ends and wherever the UDLs are changing, right? Very good. You are absolutely right. Minimum 4 points. I'll take one extra point because I want to use it for certain purpose going forward. Okay. So you are absolutely right. Those who said 4 points are absolutely correct. I'll take this point additionally. So this is an additional point. There is no technical requirement for it to be taken. So I'm saying we take A, B, C, D, E. I am again saying C was not required. C can be avoided. Am I clear, class? Yes or no?
Yes, sir.
Yes, sir.
Okay. Let's make the SF table for these points. Can you quickly make the SF table for these 5 points? If you're made for 4, no need to make again. Don't worry. If you're made for 4, it's fine. Don't redo it. You can compare the 4 points you've taken. The 5th will be automatically right. Okay. So Ajay, if you've was that Ajay? No, Akash. Akash, if you're done with 4 points, it's perfectly fine. Don't worry. Okay.
I'm done
SF
with both
units
the
will
4
be
and 5.
tons. Okay, no problem. If you have taken 4, it's okay. A, B, C, D, and E. Is there any need to divide any of these 5 points into 2, guys? Yes or no? These 5 cells into 2? Yes or no?
No, sir, no.
No, correct?
Correct, sir.
Akshay Yadav, any need to divide the points?
Negative, sir.
Why?
Point load is not
Very
there.
good. There's no point force. Use the word point force, okay? There's no point force. So shearing force at A would be 0. We carry forward 0. What are the changes from A to B? One is the UDL of 200, that is minus 200. Other is the weight of the beam of 20 meters, that means minus 20 into 8, that is minus 160. And plus the reaction over 20 meters, that means plus 38 into 20. How much is it 38 or am I right? 38 into 20, correct, guys? No, 10 into 10, sorry. It's 40 meters, no? Sorry, it's 40 meters, correct? Correct? Okay. So how much
Yes,
does
sir.
it come? It comes plus 100. Am I right, guys?
Plus 100.
Okay, it comes plus 100. C was not required. I'm just going to C now. Plus 100 I take here. What is the change from B to C? One is half of this 40 UDL, 40 tons into 10 meters. So minus 40 into 10. Then weight of the beam minus 10 into 8. And reaction of plus 38 into 10. So guys, this becomes 400, 480, 480, 380. How much it becomes? Minus 100, it becomes 0. It becomes 0. Correct? Am I right? At T, it becomes 0. Correct, guys? Yes or no? We carry forward this 0. What are the changes from C to D? 10 meters of UDL, that means minus 40 into 10. 10 meters of beam weight, 10 into 8. And 10 meters of reaction. So this is how much? 400, 480 minus 100. Am I right, guys? Correct. We take forward this minus 100. What is the last span? 200 tons of UDL. 200 tons of, sorry, 10 meters of beam weight and 10 meters of reaction. How much does it become? It becomes 0. Have I filled in the
0.
SF table correctly based on what you learned yesterday?
Yes, sir.
Okay. Now we'll draw the SF diagram. A, B, C, D, and E. Plus 100, minus 100. You can write on what is the y-axis, that is shearing force in tons. And then what do we have? We have it 0 at A, plus 100 at B, 0 at C. If C was not there, it is still okay. Minus 100 at D and 0. Guys, from A to B, the changes are beam weight and UDL, uniform rate and reaction. All three are uniform. So they'll all be joined by straight lines. If anybody has any doubt, you can ask me. Even if you had not taken C, it will still cross it at mid length. And this will be the shearing force diagram. Yes or no?
Yes, sir.
Correct. Okay. Now from here, everybody can get the SF, yes or no? BM. Everybody can get the BM diagram from here. Can I leave it here for you to do the BM? Or does anybody need support in BM now from here? Okay. Neither you'll say you need support, nor you'll say it's okay. Do you need support for BM from here once the SF diagram is there, guys? Yes or no?
No, sir.
Yes, sir.
It's okay, sir.
What will be the shape of the BM diagram? I can tell you. Values you can keep calculating. It will be only plus. I'm looking at the SF diagram and giving you. Maxima will come at C. First it is base to vertex, then vertex to base. So it will be like this. Mirror image of the set, like something like a bell.
Yes,
This will be the shape of the BM diagram. Those of you who have drawn. Yes or no?
Yes, sir. That's right.
Correct, class? Bolo bhai, will this be the shape of the BM diagram once you get the values?
Yes, sir. Yes.
Guys, have you drawn it or not? Akash, you wanted to match it.
Yes,
What
sir,
did
sir.
you get?
Yes, sir. Sir, same, sir. Correct.
I have removed that. Sorry. Yeah, Akash, sorry guys.
You're coming broken.
Yeah, Akash. Am I audible now? Sorry. Akash, did you get
Yes,
this
sir.
BM
Yes, sir.
diagram?
I've got the same diagram, sir. Yes.
Okay, very good. Anybody who needs support in BM, please tell me. Okay. I'll carry forward this SF diagram to the next page. And I'll stop this question here because you will be able to now complete it. And now I take you to this question. Look at this question which has come up on top. A box-shaped vessel, 40-meter long, light displacement 320 tons, is divided into 4 holds of equal length. Hold 1 and 4 are loaded with 200 tons of cargo, trimmed level, and 2 and 3 are loaded with 400 tons of cargo each, trimmed level. Draw the SFBM diagram. If I make this ship, the diagram will look like this. This is the box-shaped vessel, 40 meter in length. When you divide it into 4 holes of equal length, each will be 10 meter long. Its light displacement is 320 tons. Hold 1 and 4 are loaded with cargo, 200 tons each and trimmed level. So it has 200 tons at the rate of 20 tons per meter. It has 200 tons at the rate of 20 tons per meter. 3 and 4 are loaded with 400 tons each, trimmed level. $400 tons each at the rate of 40 tons per meter, for the rate of 40 tons per meter. Do you agree with the cargo distribution I've shown, guys? Yes or no? Do you
Yes,
agree
sir.
with me, class? Okay. Now, guys, in such questions, even if it is not said, we have no choice but to assume that this light displacement is uniformly distributed. I know in a ship, light displacement is not uniformly distributed. Why? Somewhere you'll have machinery. Somewhere you'll have cargo gear. Somewhere you'll have winch and windlass mooring gear. Somewhere you will have something. Somewhere the thickness of the plating will be more. Somewhere the thickness will be less. Somewhere the frames will be closer. Somewhere the frames will be far apart. So if you say in a ship the light displacement is not uniformly distributed, you are 100% correct. But if it is not uniformly distributed, then the question must provide me the complete details. How is it distributed? Now, in the absence of that detail in the question, the only thing you can do is that this 320 tons will be assumed to be uniformly distributed. Am I clear, class? Yes or no? Is that clear?
Yes, sir.
Yes, sir.
Now, guys, if 320 tons light displacement is uniformly distributed, and here is the midship, light displacement on both sides of midship is uniformly distributed. Cargo weight on both sides of midship is exactly symmetrical mirror image. Your 400, 400, 200, 200. So what does it mean? That the weights on the ship and the weight of the ship is symmetrically divided about midships. Do you agree? Yes or no?
Yes, sir.
It is the box-shaped vessel. So if the weights are distributed symmetrically about midships, can you tell me how the vessel would be floating? Would it be floating on even keel or would it be floating with some trip?
Even
It's
keel.
a box.
Even keel.
Does everybody agree with your knowledge of law of flotation and ships? Now, whatever be the draft, I'm not talking about draft. Do you agree with me that the vessel will be uniform, will be floating at an even keel draft? Whatever the draft, we are not saying draft is less or more. Am I right? Correct? Correct, beta? Yes or no? Anybody
Yes,
who
sir.
does not agree?
Correct.
What is the displacement of this ship now? It is 1520 tons, 320 tons plus the cargo, 1520 tons. What is supporting this 1520 tons, guys, for the ship? What is supporting it?
Buoyancy.
And how much is buoyancy? It will be equal to displacement,
Same.
1520 tons. What is buoyancy? The weight of the underwater volume, in this case, intact ship. Guys, tell me, it's a box-shaped vessel. So if I take every 1 meter length from one end to the other, is the volume displaced by every 1 meter same? Yes or no?
Yes, sir.
Yes, sir.
So what does it mean? That means buoyancy is uniformly distributed. Correct, beta? Correct?
Yes, sir.
Yes, sir.
So that means this buoyancy of 1520 tons is uniformly distributed at 38 tons per meter, 1520 divided by 40 meters. Correct, beta?
Correct, sir.
So in this case, the vessel is supported by buoyancy. In this case, the beam was supported by reaction. That is the only difference. Correct, beta? Otherwise, you see, if I now take only this part of the diagram, which part? The part I'm going to draw orange now. If I take only this part of the diagram, this one, this one, this one, this one, this one, this one, this one. And does it become a beam like this? Yes or no, beta? Correct?
Yes, sir.
That means I remove this part of the shell, it becomes a beam like this. And where do I bring the thing? The buoyancy is supporting it. That becomes the reaction, which is uniformly acting along the entire length. Do you agree with me that this box-shaped vessel can be represented by this beam? Yes or no?
Yes, sir.
Yes, sir. Yes.
This box-shaped vessel can be represented by this beam, which I gave you as homework yesterday. Yes or no?
Yes, sir.
If this box-shaped vessel translates into this beam, then this SF diagram and this BM diagram would be the SF and BM diagram of this box-shaped vessel also.
Yes.
Yes or no?
Yes, sir.
Yes, sir.
Correct. So here, what have I done? So this question which I gave you as a homework was with an intent to swiftly switch over to box-shaped vessels or any ship type vessel. So what am I trying to say through in this discussion? That every vessel, whether box-shaped, non-box-shaped, ship-shaped, whatever, every vessel can be represented as a beam. Do you agree with my statement? Yes or no?
Yes.
Every vessel can be represented by a beam. But
Beam.
is the beam going to be so simple as in this case? Well, it may be. But then every time your situation may not be so simple. Why? Because the vessel may be floating in a trimmed condition. If it floats in the trimmed condition, then buoyancy is not uniformly distributed. The cargo in the holds may not be trimmed level, it may be sloping. So weight of the cargo is not uniformly distributed. So what happens? It is true that every ship, every vessel can be translated into a beam, but whether it will translate it into a simple beam or a complex beam will depend on the complexity of the situation. Do you agree with me? Yes or no? Correct?
Yes, sir.
So if it is a simple beam, then you know how to deal with it. Like this you could have solved, but then it can be a complex one also. So yes, I'm all denying, I'm not at all changing the statement. Please remember, every ship can be translated into a beam. Only thing is, it may not translate into a simple beam, it may translate into a complex beam. Can complex beams be solved? Yes, they can be solved, provided you attain higher degree of proficiency. Mathematical proficiency will definitely be able to solve. So now, if I don't have attain higher degree of mathematical proficiency, and I still want to draw the SFBM of a slightly complex nature, then what do we do? To deal with the complexity, we don't usually route the vessel shape via beam. But one thing you have agreed, that it can be translated into a beam. But because we don't want to get into a complex beam scenario, so what do? We, for such cases, usually we route ourselves through a slightly different route. And what is that slightly different route? Right now, what have you done? You are drawing the beam diagram. Then you were getting the SF diagram. And then you are getting the BM diagram. This was the route you're following until now? Yes or no, beta?
Yes, sir.
Correct? Now, equivalence of beam diagram is the vessel diagram, as we have drawn here. SF diagram leading to BM will remain same. But to get SF, we will introduce one more diagram in between. And that diagram will be called as the load diagram. This is just to make things easier. Otherwise, it can be translated into beam and still solved. I'm not denying it. So basically, now we'll take this route for the ship-shaped or box-shaped vessel. And our syllabus is only box-shaped vessel, so this is the route we'll take. So we'll learn to draw one extra diagram called as the load diagram. Then by areas under the load diagram, we'll get the SF diagram. And then from SF diagram to BM diagram, all of you know. So today we know that had I converted this ship into a beam, this would have been the SF diagram, correct, beta? 0 minus plus 100, 0 minus 100, 0. This is the SF diagram you would have got? Yes or no, beta?
Yes, sir.
Yes,
We
sir.
will now solve this question via the load diagram route. We'll solve this question via the load diagram route, and we'll see that we get the same SF values to establish credibility of the system. And thereafter, we'll forget converting them into beam shape. So it is just to link the process. So what is the new learning today? New learning today is going to be how to draw the load diagram. What do you understand by load diagram? Now pay attention now. And anytime you don't understand, unmute and let me know. First thing you will do will be you'll draw the box-shaped vessel diagram. And I'm drawing it here. I hope this is visible. If there is any problem, let me know. I can change to a darker one better. This is 40 meters. Breadth is not given, whatever be the breadth. As per the question, it is divided into 4 holes, each of 10 meters. Light displacement is 320 tons. And since we are assuming it to be uniformly distributed, you don't have to say anything. It's at 8 tons per meter. 1 and 4 contain cargo of 200 tons each and spread over 20 meters, 10 meters. So it will be like UDL at 20 tons per meter. You have 200 tons here at 20 tons per meter. You have 400 tons here each, which was given as 800 tons over that
आपका फोन
land.
कहाँ है?
Better mute yourself, please.
हाँ इधर
Please
रखो,
mute yourself.
कनेक्ट उससे नेट से कनेक्टेड आप.
Please mute yourself, guys. Please mute yourself, please. Okay. And now this vessel will be floating at some even keel draft because the way weights are distributed. Light displacement is uniformly distributed. Cargoes are symmetrical about midship. So vessel will float on an even keel condition of whatever draft, doesn't matter. So guys, now we have the light displacement equal to 320 tons at the rate of 8 tons per meter. We have cargo distributions written. Now, buoyancy is equal to displacement is equal to 1520 tons at the rate of 38 tons per meter. Why buoyancy is uniformly distributed? Because it is box-shaped on even keel. Box-shaped plus even keel. If it was not box-shaped or if it was not on even keel, then buoyancy will not be uniformly distributed. Am I clear, class? Yes or no? Am I clear, class?
Yes, sir.
Yes, sir.
Okay. Now we'll look at the way we were looking at beam diagram. We'll look at the box-shaped diagram, and the same thing. Wherever you see changes happening, we'll select those points. Yes, you can manage with the 4 points, but since there is a bulkhead in the center, we can take the additional point. This midpoint could have been avoided, like we could avoid in the beam. Here also we could have avoided it, but since there are bulkheads, so normally we continue making it simple, working it at all the bulkheads. Now guys, we'll learn to make the load table. Now this is the new learning, and you can ask me if there is a problem. Guys, we'll make load table for 5 points. We'll have the points here, A, left to right, C, D, E. So we'll continue moving from left to right, guys. Okay. Guys, here the load does not mean downward force. In this context of this load diagram, the meaning is slightly different. It is not the downward force. Here in the load diagram or load table, what is load? Load is the resultant at any point of upward and the downward forces per unit length. So it is the resultant of downward and upward forces. Okay. What are the downward forces acting in this case, guys? Name the downward forces. Only the name them. Don't give me the values.
What are the downward weight of the cargo?
Very good. Light displacement and the cargo. So first, let's deal with the downward forces. Light displacement. In which units? Pay attention to the units. Tons per meter. Now guys, light displacement is uniformly distributed at 8 tons per meter from one end to the other. But to the left of end A, is there any light displacement?
No, sir.
Is there, and is to the right
No.
of E, is there any light displacement?
No.
No,
So
sir.
we will divide the end points into two parts. To the left of A, light displacement is 0. As I come to just right of A, it becomes 8 tons per meter. It remains 8 tons per meter at B, 8 tons per meter at C, 8 tons per meter at D, 8 tons per meter at E or left of E. And the moment I go to right of E, it becomes 0. Do you agree with me, guys? Yes or no? Correct? Anybody has any questions how this first row of light displacement in tons per meter has been filled up? Anybody has any questions, guys? None? Okay. The second downward weight, you rightly said, is the cargo weight. In which units? Tons per meter. Now look at the diagram. At which points do we have the different cargo weights on each side of the point? On each side of A, is it same or different? Look at the beam box shape diagram. Is the cargo weight per unit length same or different on each side of A?
Different.
Different, sir.
Point B.
Different.
C.
Same.
D different, E different. So wherever it is different, we'll divide it into two parts. One will be the left side, other will be the right side. So A, it is different. B, it is different. C, it is same. So C, we have not divided. And the cargo weight per unit length to the left of A is 0. To the right of A is 20. To the left of B is 20. To the right of B is 40. Both sides of C is 40. Here it is 40. It is 20. It is 20. It is 0. Please have a good look at it and tell me if you have any doubt. Class, tell me.
ठीक है सर.
Is there any other downward force? No. So
No,
we'll
sir.
add both of them and we'll get the total weight which is acting downwards. Total weight in tons per meter. Now guys, whichever cells in 1 or 2 were divided, whether in 1 or 2 or both, they will all be divided in the total. So that means this will be divided, this will be divided, and these two will be divided. Now, what will be the total weight just to the left of A? 0 cargo, 0 lightweight becomes 0.
0.
Just to the right of A, it becomes 8 plus 20, 28. Wherever it is not divided like in B, it will apply to both sides, left as well as right. It is same, so that's why it is not divided. So it will be 28 and 48. It will be 48. It will be 48, 28. It will be 28, 0. Does everybody agree with me? Yes or no?
Yes, sir.
Perfect.
Guys, is this force acting downwards or upwards?
Downward, sir, this one.
Downward, sir.
And are we going from left to right or right to left?
Left to right.
Left
So
to
when
right.
you go from left to right, downward forces are positive or negative?
Negative.
Negative.
When you go from negative,
Negative,
so we put negative sign in front of each of them. Instead of putting negative in all the above, we can just put it here in the total. So column 1 and 2 is now summed up in this red column. So 1 and 2, the job is done. What is the other force acting on the vessel? Is the buoyancy upward. There is only one upward force which is acting, and that is buoyancy. Because the vessel is box shaped and on even keel, buoyancy is uniformly acting. We have already discussed under the box here. We have already discussed it. But is there any buoyancy to left of A and right of E, guys, like the light displacement?
No, sir.
No,
We'll
sir.
divide we divide this and this into 2. Rest everywhere the buoyancy per unit length. Please pay attention. All these units are tons per meter, tons per meter, tons per meter. 0, 38, 38, 38, 38, 38, and 0. Guys, does buoyancy act upwards or downwards?
Upwards.
And we are going
Upwards.
from left to right. So left to right, upward
Positive.
forces are positive.
Plus-
So we put
plus
a
sign.
positive sign. The resultant of these two columns, red and green, is the what we call as the load. Okay, it is not the downward forces this time. So what is the load along the length of the vessel at different points? Load. What will be the units? Tons per meter. Which will be divided? Whether something is divided in this third column row or the fourth row. Those cells will be divided. So obviously this will be divided. They are divided in weight, and this will be divided. Now you know how to add or subtract them. It will be 0. It is plus 10. If somebody
10
does not
plus
understand,
10
let me know. Yeah,
minus 10.
please always speak to yourself with sign. Don't say 10 as plus 10. Always say plus 10. Don't miss out. Otherwise, you'll mess it up somewhere. Have I filled in correctly, class? Is it clear, class?
Yes, sir.
Now, we'll make the load diagram. Now, on the y-axis, I'll have the load. In which units? Tons per meter. A, B, C, D, and E. Since the values are symmetrical, plus 10 and minus 10, I can take plus 10. And same distance on the other side, I can take minus 10. Now, we'll draw them. At A, it goes from 0 to plus 10. Then it remains plus 10 up to B. And at B, it changes to minus 10. Then it remains minus 10 to C, remains minus 10 up to D. So this is plus 10, this is minus 10. Becomes plus 10 at D, remains plus 10 and becomes 0. Please see, do you agree with the load diagram based on the load table? These values have been translated into a diagram. Clear, beta? Zero to plus 10, then plus 10, then minus 10, then minus 10, minus 10, plus 10, plus 10, 0. Correct, class? Yes or no? Each of these are 10 meters apiece. Guys, take 5 seconds and let me know if you have any concerns. Clear? Clear, class?
Yes, sir.
Now we'll make SF table. Now the job of the load diagram and the box shape diagram is done. Now we'll make SF table by looking at the load table, and what am I writing? By areas under load diagram. See what am I writing? Guys, the same rule, whatever applied from SF to BM. Now your focus is on load diagram. How many points? All the points for which you took the load diagram for load table, they automatically have to be picked up. And any other extra point where the load diagram may cross the x-axis, they have to be added. So have you understood how to decide on the points for SF table now? It's the same rule as you applied when you are making BM table from SF diagram.
Is that clear? Clear, class? Follow me, fatafat.
Yes, sir.
Yes, sir.
So based on this, how many minimum points should I take for SF table?
Same
How
as
many?
before, sir. 5 points.
How many? 5 points, because we have taken 5, so we stick to 5. And now the area will not change suddenly, so no need to worry about dividing into 2. Division always happens in the first table, if at all. Now SF will be in tons. Why, beta? This is ton meter, this is meter. When you multiply, the area will come in tons. Same way as you were dealing with the SF diagram, can you deal with me? What is the area under the load diagram to the left of A? How much? To the left
0.
of A, how much is the area under the load diagram, class?
0.
0. I carry forward 0. What is the change from A to B? Plus 10 into 10. Am I
10.
right?
Yes, sir.
Plus 10 into 10,
Plus
making
100.
it plus 100. I carry forward plus 100. Look at the diagram again. What is the change from B to C? Minus 10 into 10, making it 0. I carry forward 0. What is the change from C to D? Minus 10 into 10, minus 100. I carry forward minus 100, and the change is plus 10 into 10 is 0. Correct, guys? Yes or no? Simple to get SF?
Yes, sir.
And now we make the SF diagram. A, B, C, D, and E. Plus 100, same distance, minus 100. SF units will be now tons. And guys, now I first put the points and then you'll shape it by looking at the load diagram. It's 0 here, it's plus 100 here, it's 0 here, it's minus 100 here, and it's 0 here. Look at the load diagram from A to B. Is the area changing at a uniform rate from A to B? Yes or no? Only the answer has to be yes or no. Is the area in the load diagram changing uniformly?
Yes, sir.
Yes,
So
sir.
it will be joined with a straight line. Is the area from B to C changing at a uniform rate?
Yes, sir.
Yes, sir.
C to D? Yes. So they'll all be in a straight line, basically like this. And likewise, this will be a straight line. See this SF diagram and compare with this one, guys. Is it the same SF diagram that we are getting there? 0 plus 100, 0 minus 100, 0. Yes or no? Am I right?
Yes, sir.
This one we got through the beam route. This was through the beam concept. And this one we have got through the load diagram. Can you all get from this SF diagram now the BM diagram, or does that need any help? I don't think that needs any help. Yes or no?
No, sir.
So guys, I will just give you 5 more 10 seconds, 15 seconds for you to ask me doubts, and then I've shared the sheet with you. I'll tell you which all questions can you attempt today, because I have to then move out to the airport. I'll not be able to stretch it by 15-20 minutes today the way I used to do it on other days. So let me know if anybody has any concern on the load table, load diagram, and then getting the SF diagram from the load diagram. And SF to BM you have already done, guys, so many times with the beam. It applies the same concept. The concept remains the same. Is it clear, beta?
Yes, sir.
Is it?
Yes, sir. Clear.
Okay. Now let me just take you to the sheet. Which questions can you do? I'm closing this, guys. If anybody wants to take a screenshot or something, please do it. I'm closing this. I'm closing this out. And now in the last question, guys, in the sheet that I have sent to you, this is the sheet that has come to you, 2 of them. What all questions can you do? This first question we have just done. Okay. Second question, you can do this one. Third question, you can do. Fourth question, you will not be able to do. Fifth question, you can do. So first, second, third, fifth, and then 8th, 7th. That's all. So guys, you can write down the question 7, 8 in the sheet I've sent you, and 7, 8, and these ones. So first 1, 2, 3, 5, 7, 8. 1, 2, 3, 5, 7, 8. And if you see, barring one, rest all questions are from MMD, guys. They're all from MMD exams. Okay. So do them. If there is any doubt, I'll take it day after tomorrow, guys, or tomorrow. And tomorrow we are meeting at 13:30. Okay. Tomorrow we are meeting at 13:30, guys. I'll put it on the group also.
Sir, हेलो
हाँ
सर, कल 2 क्लासेस है, 5 बजे भी है इवनिंग?
नहीं, 5 बजे नहीं है, 13:30 ओनली.
ओके सर, ओके.
शेड्यूल में सर था ना 5, तो वो दैट
अच्छा, शेड्यूल में था क्या? शेड्यूल में था. So let's have 2 classes tomorrow then, no problem. Doesn't matter. We'll have 2. Okay?
Okay, sir.
Okay. Let's meet at 13:30 and then we'll see. Don't worry. ठीक है?
Okay, sir. Okay, sir.
Okay, guys. I'm logging out. Take care. Bye.
Thank you.
Bye.